All right, so for the last section of this unit, because we are having a test next week, we're going to specifically talk about some things that we can do to function equations. So last class we kind of focused a lot on graphing. And so today we're going to look at some algebraic ways that we can combine functions. All right, so it turns out that you can perform any of the four basic operations on functions. So you can add, subtract, multiply, and also divide two or more functions. And you don't have to worry about when you do these operations that it'll somehow make the result no longer a function. But you do have to be concerned about the domain. So we're just going to say that the domain may change. It may not, but we have to be aware that that's a possibility. Okay, so first let's look at a few functions and maybe learn how to read these addition, subtraction, multiplication, and division problems. So let's say that you have the following functions. Okay, now remember, to review, you should kind of know what the graphs of all of these are based on what we did last week, right? Notice this is linear, so it would be a line when you graph it. This is an absolute value, so it would be a v when you graph it. And this is a rational, so it would be like a set of a couple curves that are not continuous. Okay, so that's not really what we're doing today. I'm just saying you can kind of review as you go here too. All right, so let's say that I want you to find the value of the following things. So first we need to learn how to say these things. This does not mean g minus h multiplied by 2. Okay, this means g minus h of 2. Okay, so it's function notation. So don't try to think that we're doubling anything. That's definitely not what we're doing. G minus h of 2 means take g of 2 minus h of 2. Okay, it's function notation, and that's literally what it's asking. So remember, g of something just means go to your g equation, right, and plug in whatever number you have. So I'm going to have the absolute value of 2 plus 4 for the g of 2. And then I'm going to subtract whatever I get when I plug in 2 to the h equation. So I'll get 1 over 2 minus 3 for that one. And then just work these separately. The absolute value of 2 plus 4 is 6. Okay, this works out to be 1 over negative 1. So then you have a minus a negative 1, okay? So we'll go ahead and write that. So it ends up being minus negative 1, which of course changes to a plus. So the answer there is 7. Okay, so we're still finding a y value when x is 2. It's just that we're taking two functions and subtracting them, okay? So not surprisingly, this one is asking for you to divide h of 7 by f of 7. Okay, so h of 7 would look like 1 over 7 minus 3. That's going to be the numerator. And then f of 7 is going to be whatever 2 times negative 7, or sorry, 2 times positive 7 is. Okay, so that's going to be 1/4 divided by negative 14. Okay, when you have a fraction within a fraction, just remember that this is really the same as 1 over negative 14. So it's really just the same as saying 1/4 times 1 over negative 14, but at any rate, you get negative 1 over 56. Okay, notice I moved the negative sign to the top. Okay, you don't have to do that, but the negative sign can go on the bottom or the top. It just means the fraction is negative. Okay, so let's look at 3 different functions. So we have r, which looks linear. We have p, which is quadratic. And then we have q, which is a square root function. All right, so I want you to find the following function and I want you to tell what the domain would be. Remember, domain is what is x allowed to be, okay? And so remember, we have two rules we don't want to break with domain. We don't want 0 in the denominator right now, and we don't want negative numbers under the square root. All right, so let's say that these are the two functions that I asked for. Notice this time I don't give you a number to plug in, I just say of x, okay? So again, this would read as r plus p of x, okay? And then this would be q divided by r of x, so on and so forth. So r plus p of x means r of x plus p of x. So we don't have a value, we're just going to add the equations themselves. So it's going to be negative 3x plus whatever p is, right? So it's x squared plus 3x. And then we'll want to combine like terms. So if we add these, we'll get x squared, and then minus 3x plus 3x cancels out. So my new function is x squared, okay? And then if I'm asked to find the domain, remember, I'm looking for restrictions on x, and notice there are no restrictions on x. So if you can't find anything that that x cannot be, then it just means the domain is going to be negative infinity to infinity. You're going to find that your domain is going to be negative infinity to infinity somewhat regularly. Okay, if there's no restrictions on x, then that's what it is. All right, so here we've got q of x divided by r of x. Okay, so we're just going to take that square root function, that's q, divided by the linear function, and that's r. There's nothing at all we can do to simplify this. Like, that's it. Okay, we can't cancel from within a square root, so you have to leave it alone. Okay, but we do have some domain issues here, right? So we have to remember the two rules, right? For domain, I think I already mentioned these. Remember, no 0 in the denominator. And remember, I only want positives under the square root. Okay, so notice I'm going to have both issues here with the domain, so I'm going to need to be careful about both of those things. Okay, so let's start with the first one. Okay, so on the one hand, we don't want the denominator to be 0. So if you set the denominator equal to 0, or not equal to 0 rather, then we find that x can't be 0. So remember before when we did a number line and I told you it was optional? Okay, it still is optional, but I just think if you're a more visual person, it does help. So we want to kick out 0 so far. 0's out. Okay, so that's domain issue number 1, but we also have domain issue number 2. We want 1 minus x to be positive, and that's how we say it mathematically. We say greater than or equal to 0. So we did one like this a while back, but we're going to subtract 1 from both sides, so we'll get negative x is greater than negative 1. But then when I try to get my x to be positive, notice I'm dividing by a negative number, which means I'm going to have to flip that inequality sign. So it's going to be x cannot be 0, and then x has to be less than 1. So up here on my number line, I've got more going on now. So I'm going to make these a little taller. So I want everything 1 included, but then I want to go back. Okay, I want to go less than. Okay, but I still have to be able to kick this number out. So the picture's not required. The domain and interval notation is required. Okay, so the domain, if you read from left to right, would be negative infinity until your first stopping point, which is 0. And then we'll pick back up with 0 and end at 1 with a bracket. Okay, so kind of like I told you before, the picture is not necessary, but I do think the picture helps you get where you need to be. Okay, this is where I want you to be as far as domain goes. I want you to list it in interval notation. Okay, so let's look at another example. So let's say we have the following 3 functions. S, T, and also V. Notice S and T are rational functions. Anything with x in the denominator is a rational function. And then V is a square root function. So I'm going to ask you to find the function and the domain of the following combination. Okay, so we want s times t of x. Okay, so we're going to get the s fraction and we're going to multiply it by the t fraction. Okay, so when we try to clean this up and simplify it, I want you to see that we probably can simplify. Okay, so what we're going to do is we're going to factor these to see if there's anything that we can do. But before we do that, I want to make sure we make a note. Okay, we're going to factor and simplify so that the equation is as simple as it can possibly be. But any factor that is canceled out is still an issue with the domain. So I'm going to use quotation marks here because they're being canceled in the sense that we're going to get a simpler equation, but they're still affecting the domain, so they're not really gone. Okay, so up here, let's see if we can kind of factor this out. So notice the top of the first fraction is already kind of done. This is, we're going to talk about factoring as we go throughout the semester, but this is supposed to be something kind of quick that you know how to factor relatively rapidly. Okay, it's a difference of two squares, and it factors into x plus the square root of the second number, and then x minus the square root of the second number. Okay, we're going to practice factoring some more, but this is one that they just, you know, in this class kind of expect you to be able to eyeball and tell. And then we have the second fraction. Okay, so I want to talk about this denominator. Okay, notice that it's super close to this one, right? But the signs are off. In other words, everything keeps the sign that's in front of it. So this one, the x is positive and the 2 is negative. And this one's the opposite, right? The x is negative and the 2 is positive. Okay, so what we're going to do with this guy right here is we're actually going to pull out a -1, or think of it like dividing by a -1. Because when we do that, it's just going to change the sign of both of these. And so we're doing that for the sole purpose of we'd really like to cancel it out with this guy right here. Okay, so we're going to end up canceling this and this, and then we're going to end up canceling this and this. So in the end, we don't end up with anything left on the top, so we're going to go ahead and make that a 1. Okay, anything, we have to have something on the top, so we're going to say 1. And then we're going to have over x plus 3. And then as far as the negative sign goes, I'm just going to put it on the top. Now you could also put it on the bottom and have 1 over negative parentheses x plus 3. Okay, that would have been okay. So this is the function. We simplified it so that it would be more pleasant. But we need to remember that every time we were 0 in the denominator originally is a problem with the domain. Okay, so in other words, x cannot be -3 because of this guy. X can't be 3 because of this guy. And x can't be 2 because of this guy. Okay, because in any case, we can't have 0 anywhere. Okay, so when it goes to the point where you need to find domain, okay, we need to kick out 3 values. Here's -3, here's 2, and here's 3. So I want to say no, no, and no, right? But I want to include everything this way, everything in the middle of these, and then everything that way. So in the end, again, picture optional. This is what's required, the interval notation I'm about to write. So let's go from left to right. So -∞ to -3. Don't include -3. Then go from -3 to 2. Don't include either one. Then go from 2 to 3. And then finally go from 3 to infinity. Okay. Notice my domain has 4 pieces because my picture had 4 pieces. Okay. All right, so just be aware that we always have to be on the lookout for domain issues. Okay, and remember the main domain issues we think about right now is no 0 in the denominator and no negatives under the square root. Okay, so we're going to look at a very specific formula. We're just going to look at the algebraic side of this formula, but just know that if you are in calculus or if you take calculus at some point in college. This has some calculus applications. Okay, we're not going to talk about calculus, so don't freak out and think we're going to. I'm just making the reference that this is something you'll see again if you take calculus. If you're not going to take calculus, we're just going to think of this as a version of slope. So remember, slope is normally change in y over change in x. And so there's a very specific slope formula, which I know looks a little strange, okay? And it's definitely a little extra from our original slope formula, but this is still just a change in y over a change in x, okay? And so the shortened version of this formula, it's called the difference quotient. Looks like this right here, and then they simplify the bottom. X minus x cancels out, and so you just get h. Okay, but all this is just a version of slope. Okay, this is still a change in y over a change in x. It's just a little fancier than we're used to. Okay, so all we're going to do is actually find the difference quotient, and then if you do take calculus, there are some things you'll do with this. Some pretty important things, actually, but we don't need to know that in this algebra class. All right, so let's say I asked you to find the difference quotient and simplify. In other words, all I'm really asking you to do is subtract two functions from each other and then divide by a value. Okay, so I'm asking you to perform some algebraic operations on some functions. Okay, it's just very, very specific. Okay, so let's say that this is my function that I want to work with, x squared minus 3x. I think we can all agree that this is kind of a booger-looking formula, right? It's kind of an ugly one. So when we find something that we think looks intimidating, I like to baby step it and just look at just the pieces. So let's just look at the pieces first, and then let's see if we can put it together to form this whole difference quotient here, okay? In other words, let's figure out what f of x plus h is first. Let's just baby step it that way, okay? So don't overthink that, right? Who cares that there are two letters? F of anything just means replace x with that parentheses. So instead of x squared minus 3x, it's going to be parentheses squared minus 3 parentheses. Okay, so don't forget, we've talked about this semester, but you cannot just distribute that squared when you're adding. Okay, instead you have to FOIL. So you're going to need to FOIL here, and you're going to need to distributive property here and then see what you get. Okay, so first times first, x times x is x squared, x times h is xh. Inside would be h times x, so that's another xh. H times h is h squared. And then don't forget the 3 goes to both things, so this would be minus 3x minus 3h. So you want to combine like terms, but there aren't really that many of them, right? There's only these two guys. Like, these are the only two like terms we have. We have an xh plus a second xh, so that is 2 xh's. But then, unfortunately for us, there's really nothing else we can simplify here, okay? So I'm going to circle this with my red pen here. It's not my final answer, but it's what f of x plus h is, okay? So now I think that we've done that particular piece. I think we can go ahead and plug it in our difference quotient formula. This is what I'm being asked to find. This is what the difference quotient is. Okay, so difference quotient is this formula. Okay, well, we just found this portion of it, and we got x squared plus 2xh plus h squared minus 3x minus 3h. Okay, we're going to be putting a bunch of stuff over h. I'm just trying to follow this formula. Okay, so the last piece is I need to subtract f of x. Make sure you use parentheses. So I need to subtract x squared minus 3x. So just to recap, this is f of x plus h. We're subtracting off f of x, and we're going to divide it by h. Okay, but again, we're just going to baby step it. Okay, so if we distribute this negative sign here, then we're going to get, I'm going to rewrite it all again. The first parentheses, the signs don't change, but because of that minus sign, the parenthesis, the minus sign in front of the parentheses, it changes the signs of the second parentheses. Okay, but notice with the sign change, when I try to go combine like terms, x squared minus x squared is 0. Negative 3x plus 3x is also 0. So I end up getting just a couple things left. 2xh plus h squared over h. Oh, I forgot my 3h on top. So it's 2xh plus h squared minus 3h. And then last but not least, we can cancel out an h if there's an h in everything. And notice there is, right? So this h would cancel with this one, also taking one of these and that one. So in the end, we end up getting 2x plus h minus 3 here, and that's as far as we can go. These aren't like terms. Okay, and then again, just know that in calculus, we actually do something with that result. Okay, but for now, we're just looking at the algebra portion. Okay, so I consider this type of problem to be a little tedious, especially in finding the f of x plus h part. But it's not hard. There's a difference between tedious and hard. Tedious just means we need to have some patience and stick with it. You know, hard means we would struggle to do it at all. Okay, so let's do one more. Now on Connect, you're going to get different questions than the person that sits next to you in class. Okay, everyone usually gets different questions. But there are going to be some commonalities, and so we're going to talk about those. So let's say that the function I want you to do this same difference quotient formula for looks like this time, negative 4x squared minus 2x plus 6. Okay, so again, the difference quotient is this guy, right? So I don't want to do the whole thing first. I want to just start with maybe just the f of x plus h part. Because even that is kind of a mouthful. It's negative 4 times x plus h squared minus 2 times x plus h plus 6. So if I expand it out, it's like x plus h times itself. And then I still have this distributive property going on. Okay? So we have a little more to do than we did on the last one, but the process is really similar. We're still going to FOIL this. Okay, and notice this is actually the same exact foiling that we did up here. Okay, so if you pay attention, you might be able to pull some of that, or you just need to redo first, outside, inside, last. So I'm going to leave the negative 4 and I'm going to FOIL, and that's going to give me x squared plus 2xh plus h squared. So I FOIL first, and then I'm going to work my negative 4 through this parentheses. Okay, so the negative 4 distributes to that parentheses, and the negative 2 distributes to this parentheses. So you end up getting negative 4x squared minus 8xh minus 4h squared minus 2x minus 2h plus 6. Okay, so again, the first step is actually the hardest in this equation. Okay, finding the f of x plus h is almost always the hardest part. But remember, that's not my final answer, right? What I want is actually the whole thing, right? I want f of x plus h minus f of x over h. That's what I want. Okay, so let's write down what I just found f of x plus h to be. It was negative 4x squared minus 8xh minus 4h squared minus 2x minus 2h plus 6. Phew, that's a long one. We're going to have everything over h. So we've got 2 out of the 3 pieces, but we still need to subtract f of x. So make sure that you use a parentheses when you subtract that second piece, the f of x part, because this negative sign is always going to go through and change the signs of everything. So without writing it all again, just know that these are always going to pair up. This negative 4x, this is going to change to a positive 4x and cancel with it. This is going to change to a positive, so it's going to cancel with that negative at the front. And then this is going to change to a negative, which cancels with the original plus 6. So we end up with this remaining, negative 8xh minus 4h squared minus 2h over h. Okay, after we canceled the pairs of like terms, that's all we had left. And then just like example 4, notice what we can do next. There's an h in everything. So with the fraction, we can cancel it out. And so in the end, we just get negative 8x minus 4h minus 2. Okay, so if you can stick with it, the individual steps to this problem are not that difficult. There's nothing more difficult than foiling and distributive property. It's just that you need to go slow enough and maybe work out the most difficult piece, which is f of x plus h, off to the side before you begin. Okay, so we've talked about some different ways to add, subtract, multiply, and divide functions. The difference quotient was a combination of subtracting and then dividing by something. But there is a final way that we can combine functions together, and it is different from the 4 operations we've been discussing. So composition of functions is actually something we do somewhat regularly in algebra, but it's where you plug one function into another. The symbol for composition of function is actually a small open circle. So I have a marker that I'm using to write this. It makes it look like the letter O or something, but it's not that big. Okay, it's more like a multiplication dot that's open. Okay, so if you see that operator, and again I'm going to try to make it tiny. Okay, it's not fog, it's F composition G. Okay, that's how you read it. And it literally means that they want you to put G inside of the function x. Okay, and you would say this as f of g of x. Okay, so you just kind of read it from left to right. And so a good rule of thumb with these is always start with the inside function first. And if you can remember that, and again, just take it kind of baby steps at a time, then I think you should be able to do these. Okay, so let's look at some problems where you're asked to do composition of functions. So let's start with 2 relatively simple functions. So n looks linear and p looks quadratic. But let's say that I asked you to find this quantity. Okay, so this operator means composition of functions. It literally means I'm asking you to find n of p of -1. So remember my hint, you always start on the inside. Okay, so in other words, let's figure out what p of -1 is. We know how to do that already. We've already practiced this about a week ago. Okay, p of -1 just means go into your p equation and replace it with -1. So we get -1 squared minus 9 times -1. So we end up getting 1, because that would be positive 1, right? A negative times a negative is a positive, and then plus 9, so we get 10. But that's not my final answer, right? That's just what p of -1 is. Okay, so now I need to come back up here and I need to say, okay, now I need to find n of 10. In other words, I'm going to start here. I know p of -1 is 10, so now I'm just finding n of 10. And of course, that just means go plug in 10 to the n equation, and we get a result of 5. Okay, so this is kind of like the side work. Okay, we do the inside first, and then we plug whatever we get into the outside function. All right, so let's take these same equations, but let's say I asked you to find p of n of x and its domain. So part of this is just knowing how to read this. When you see that composition operator, then it means p of the n of x function. And so as always, we always start here. Okay, so we are just going to leave the p part alone, okay, and we're going to plug in what n of x is, right? N of x is x minus 5. Okay, so we're replacing the inside with what it's equal to, right? And notice I was given at the beginning that n was x minus 5. But then this just means go to your p equation, which is here, right, and plug in x minus 5. So instead of x squared minus 9x, I'm going to get x minus 5 squared minus 9 times x minus 5. And then I just need to make sure I can FOIL and distributive property appropriately. Okay, so I've already practiced this today, right? So I'm just going to FOIL here, and I'm going to distributive property there. So I end up getting x squared minus 5x minus another 5x. Negative 5 times negative 5 is plus 25. Negative 9x is what negative 9 times x is, and then negative 9 times negative 5 is positive 45. So go through and replace like terms, or combine like terms rather. So x squared's alone, but I have negative 5, take away 5, which is negative 10. Take away 9 more, which is negative 19x. 25 and 25 is 70. So I end up with a new function by putting in inside of the p function, okay? And then I'm just asked to find the domain. But remember what I said before, if there are no restrictions on x, which there aren't, right? There are no fractions, there are no square roots to even worry about in this one, then the domain is just going to be negative infinity to infinity. Okay? Another way to think of that is that you know this is a parabola, right? And parabolas have domains of negative infinity to infinity. Okay, so let's look at maybe one more where we have two functions. Generally speaking, it does matter which order you start in. In other words, it matters what the inside versus the outside function is. There's only one specific type of function pair that you will get the same thing when you go both ways using composition of functions. So first I want you to find n of r of x, and then I want you to find r of n of x. Okay, and we are again not expecting to get the same thing here because we switched the order. So this is the same as n of r of x, right? That's how we rewrite it. And again, we always start on the inside. Okay, we don't mess with the outside first, we mess with the inside first. So I carry down the outside function, and I'm just going to replace r of x with what it's equal to. Okay, so I'm going to find n of the absolute value of 2x plus 3. Okay, so I know that looks strange, but remember, it doesn't matter what goes here. I think we did one in class about a week ago where I said find the function value of the word Texas, and it didn't matter what it was, right? We just plugged it in. So here's my function for n, and I'm just going to stick that in for x. So it's just going to be 2x plus 3. Make sure and write your absolute value bars kind of large so that you don't think they're ones or something, and then minus 2. Okay, and we can't go any further with that. Okay, things that are in the absolute value would need to stay there. You wouldn't be able to combine the 3 minus 2. If I ask you to find the domain, remember there are no restrictions on x. Okay, there might be some restrictions on y. In other words, remember the answer will only be like a positive something minus 2, but that's not describing what happens to x, right? X can be anything at all. We can plug in anything we want for x. So the other side is not the same, right? Because the other side, we're not going to start with r, we're going to start with n. So we're going to have r of x minus 2. So what that's asking us to do is plug x minus 2 into our r equation. So instead of x, we're going to have absolute value of 2 times the parentheses plus 3. Notice the structure stays the same, right? It's 2 times something plus 3 because this was 2 times something plus 3, and then absolute value bars. But then because we're inside the absolute value, we can clean this up a little bit. So keep the absolute value bars, but go ahead and distribute. So 2x minus 4 plus 3, which would reduce to 2x minus 1 absolute value. Okay, and for the same reason that I said before, the domain here is not restricted, so it's just negative infinity to infinity. Okay. So if you can always start on the inside, these composition of functions really aren't so bad. All right, so let's do one where maybe we have to kind of think outside the box a little bit. let's say that I give you that h of x is x minus 8 parentheses squared. And I tell you that h is a composition of functions of some sort. Okay, that's what I'm telling you by writing that. I'm telling you that h is made up of two functions, f and g. And that's what I'm basically asking you to find in this one. So essentially what I'm asking you to do is to find the inside and the outside functions. That's what I'm asking you to identify. Okay, so I think the inside function is pretty easy, so let's start there. First of all, let's start with, we know we have f of g of x, right, which is the same as f of g of x written in this way. Okay, so the inside function is g of x. So what would be the inside function when you look at this? Notice we have a x minus 8 and then we're squaring that thing, right? So the inside is simply what's ever inside the parentheses. Okay, that's pretty easy. Okay, but the outside function I think is maybe a little bit stranger. Okay, first of all, we're talking about f of x, right? Just because of how it's written, right? G of x is the one that's inside, f is the one that's outside. Okay, so what you have to think about is, what did I do with this x minus 8? Okay, notice that I squared it, right? So f of x is actually just going to be x squared. Okay, because we're not multiplying these, we're sticking this inside of this. Okay, so notice it does work, right? Notice that f of g of x would be, for us to stick this inside, so it would literally be x minus 8 squared, which is the same thing as h of x. Okay, so I think the inside function is pretty easy to pick out. The outside function, you just have to think about what's happening to the inside thing. And what was happening to the inside thing was it was being squared. Okay, so this is going to be the last question. We are going to show a graph. And then we're going to see if we can figure out some quantities from that graph. So rather than looking at equations, we're going to be looking graphically. So it's going to take us a minute to graph. So I'm going to go out 5 in every direction. I'm going to do what I usually do in class, which is I'm going to write out the points that I want you to graph, and then if you want to, you could pause the video and kind of plot them yourself, and then you could kind of continue on from there. So I'm going to use 2 different colors because we're actually going to have 2 different graphs. Okay, so we're going to have, I'm going to write this over off to the side. So we're going to have f of x, okay, and f of x is going to have the points -2, 3, which is open, 0, 3, and 5, -2. So I'm going to do mine in red. So again, you can kind of pause the video, but -2, 3 I'm going to make open. 0, 3 is there, and then 5, -2 is about here. So I want you to make a flat line there, and then just kind of draw a line through there the best that you can. Okay, and we're calling this f of x. And then we'll do the same for g of x. I'm going to use a different color just to really show that they're different. So for g of x, I want you to graph the points -4, -2, 0, -2, and 4, 2. And we'll say they're all just regular points, just closed points. So -4, -2 is here, 0, -2 is here, and then 4, 2 is here. So this is going to have this flat piece and then come this way. Okay, so this is g of x. So you don't necessarily have to write down these points. That just kind of gives you an idea of where to put your points so your picture matches mine. Okay, So here are the quantities I want you to find, and I want you to maybe skip a line in between them all. So we're going to find f of g of 0, g times f of 1, g minus f of negative 2, and f over g of 0. So if you need to pause the video to kind of catch up so that your graph is already drawn, then do that. Okay, so this is just asking you for f of 0 plus g of 0, which we don't have an equation to use, right? So what we have to do is use the graph instead. Remember, this is the red, right? And this is the green. Okay, so remember, f or g of 0 just means find the y value when x is 0. So here, look at the red graph, right? When x is 0, what's the y value for the red graph when x is 0? It's 3. And then what's the y value when the green graph is 0? Note here's 0, right? X equals 0, and the y value is negative 2. So the result between those is just 1. Okay, so rather than looking at equations, we're just looking at graphs. Just remember that f of whatever or g of whatever is really just asking you for the y. So this one's going to be g of 1 times f of 1. Okay, so remember g is green, right? So what's the y value when x is 1 for the green graph? Notice it looks like about negative 1 to me. Like x is 1 here and we come down to negative 1. So it's going to be negative 1 times the red graph when x is 1, it looks like about 2. So if you multiply those together, you get negative 2. Okay, so all we're doing is finding y values. That's it. Okay, this one would be g of negative 2 minus f of negative 2. Okay, so first let's use the green graph, right? So g of negative 2. Notice here's negative 2, and it looks like the y value is negative 2. So we get negative 2, but then when we try to figure out what the y value is for x equals negative 2, notice we are at an open circle, and an open circle means that it's not defined at that point, okay? So I'm just going to say plus question mark, okay? In other words, this is not defined, so if any piece of our composition is undefined, then the answer is undefined. Okay, so if we want to, we can kind of label this. This had an open circle, right? And that is not defined. Okay, so that's why we got the answer of undefined. So on Connect, there'll be a multiple choice option for you to choose undefined. And then lastly, for this one, we do f of 0 divided by g of 0. Now, we don't have to reinvent the wheel if we think about it, because we already did those. Like, we already did the individual pieces. We're just being asked to divide them. So you can do it again, or you can come up here and remember that f of 0 was 3. And g of 0 was negative 2, so it's just 3 over negative 2. Okay, so either in equation form or graph form, what we're asking for with function values, remember, is always what is the y when x is whatever. Here it's 0, here the x is negative 2, here the x is 1, and then, of course, here the x is 0.